Imagine that you're an industrial engineer part of a mineral extraction in which the process creates a contaminated site. You have an ethical and legal obligation to clean up the land, because sites that have been contaminated are a risk to human health, animals, and the environment. For example, toxic chemicals that have leaked into the soil can travel to groundwater or lakes, which can not only lead to problems with plant growth, but also pose a risk to humans and animals that use the lake's resources. These contaminants can also be inhaled, ingested, or travel to other areas by wind. How would you responsibly solve this problem? To solve this problem, there's a procedure known as environmental remediation. This involves removing pollution and contaminants from soil and water with the potential intention of restoring land or water to its original state.
Why use polymers? Polymers are diverse and flexible because of their different thermal properties, chain lengths, compositions, etc. As such, they can be used in a variety of different types of remediation methods. These methods can include ion exchange, electrochemical treatment, adsorption, and more. These methods try to remove contaminants without depleting soil or water. Because polymers are so diverse, they are easy to manipulate. For example, for an absorption process for specifically water remediation, a solid surface called an absorbent can collect the contaminants from a lake. To be able to effectively collect these molecules, polymers can be manipulated so that their pore volume and surface area increases to allow greater absorption capacity. Let's look at an example. Phenolist derivatives are generated from industrial processes such as oil refining, paper milling, wood processing, etc. These are highly toxic and you want to get rid of them. Hydrogen bonding is a big part of the absorption process, and phenols are able to form hydrogen bonds. As such, by modifying polymer structures through the introduction of functional groups that can create hydrogen bonds, you can increase the absorption capacities of the absorbents. These functional groups can include amines and carbonyls. What types of polymers can be used? An example of a group of polymers that can be used in remediation methods such as an ion exchange are known as conducting polymers, which conduct electricity. A few examples of conductive polymers include polypyrrole, polythiophene, and polyaniline.
So why use polymers over other materials? Bioremediation is the utilization of biological species, such as microorganisms, to degrade toxic compounds in a contaminated site. The biological species can absorb the contaminant and metabolize it into safe products, like water, so it could be released into the environment. This method poses risks to the environment because of the issue of containment. After microorganisms do their job, one cannot ensure that they will not disrupt the existing ecosystem or create harmful pathogens. Conductive polymers, on the other hand, undergo oxidative degradation through UV light exposure, so as to not leave harmful effects in the sites. Additionally, metals are not ideal for environmental remediation because they are susceptible to corrosion and degrade rapidly in moisture or in acidic or alkaline environments. Polymers possess the stability to efficiently remove contaminants before degradation due to their tunable properties. UV stabilizers can be applied to polymers to inhibit chemical reactions started by radiation absorption. Thank you for watching our video, and these are our references.
Created using Powtoon.